Okay. Hi, everybody. Welcome to NSCN's November Coffee House. I'm Miriam. As Dylan said, I'm a service learning student with NSCN. Jenna and Tamal are also service learning students. And I'm gonna actually first hand it over to Tamal. He's gonna do a brief introduction on NSCN and a land acknowledgement.
Good evening, everyone. I just want to say a quick few words about the Nova Scotia Environmental Network. Well, to start off, the Nova Scotia Environmental Network is a network of over 30 plus environmental organizations across Nova Scotia, whose common purpose is to conserve and enhance the natural environment and to build a sustainable future in Nova Scotia. We strive to support, strengthen, and promote the environmental work of our members by connecting them to each other, to government, and to the general public. And before we start, I would like to say a land acknowledgement. I would like to begin by acknowledging that we are in Mi'kma'ki, the ancestral and unceded territory of the Mi'kmaq people. This territory is covered by the Peace and Friendship Treaties of 1725. The treaties did not deal with surrender of the land, but did set out the rights and responsibilities that settlers and Mi'kmaq people owe to one another. As such, we are all treaty people. I'd like to hand it back over to Mario.
Okay, so we're just gonna do a brief check-in. If you could look to the chat, Jenna's gonna ask you a quick question just to make sure audio is all good for everybody. She'll put that in there in a second. See if we get some responses. Toronto, okay, Halifax. Okay, looks good. So, oh, Vancouver, we've got a lot of places. Okay. So tonight we're joined by Judy Obersi and Lori Rand. They're the co-founders of Habit Studio, a 7-person residential design firm based in Halifax that specializes in sustainable whole home renovation and new build passive house projects. Habit Studio is committed to environmental responsibility through energy efficiency, occupant comfort and health, and beauty. Their approach incorporates biophilic design principles and advanced building science to create homes that nurture the senses. So I'll hand it over to Judy and Lori there.
Thank you. So I'm Lori, and it's really exciting to see folks from all over joining us tonight. Judy and I started Habit Studio kind of a long time ago in a really informal way. We were classmates at architecture school, and then we both went away, and then we both kind of came back and found ourselves doing houses and worked together informally, and then we shared a studio, and then after more than 10 years, I think we decided that we were going to officially launch Habit Studio as a partnership. So this, our way of working together and our vision of the way houses should be has been a long evolution and a really intuitive one, but it's also, what we do is also strongly based in science. So that's who we are. And I think as we head into the presentation, I would just say that we're not going to get super technical, but we welcome technical questions because we're not really sure everybody's background. And because if we dive too deep on the technical side, we'll be here a lot longer than an hour. So first off, we're going to just talk about our approach, which, it starts with design and then incorporates the Passive House Standard and biophilia, which Miriam has already mentioned. And something else that's really important is low carbon materials and the responsible use of building products and resources. And when we put all of that together, we get what we call design for the senses. And so we're going to walk you through that, looking at an example of a recently built new house, a new passive house. And then we're also going to look at a few examples of renovation and how we approach that. And then at the end, we'll talk about what's on our horizon at Habit Studio.
Hi, everyone. My name is Judy Obersi. I'm the other half of Habit Studio. And I guess I'll start by talking about how sustainability starts with design, because we believe that being thoughtful about the design is critical to meeting the client's needs for longevity. Timelessness and flexibility of function are also important, because spaces that make people happy, it means that they will take care of them. So therefore, design is the main kind of driving force, guidance through our work.
So the fundamental passive house principles that inform our work, and we always start with this because there is occasionally confusion about passive solar and passive house. And so they both start off with making use of the energy from the sun. But with the passive house standard, we're really not maximizing the heat that we get from the sun. We're managing it and we're optimizing it. And so we do that through using high performance windows and doors. And we do it with management of solar energy, meaning we orient the building in the best way we can. And we have sometimes we might make use of things like shading devices, maybe a trellis or strategic trees and vegetation, so that we don't overheat our building. So that's the first principle of passive house design. Then we need to make our building as airtight as possible. So we test that with a blower door test a few times during construction, and it needs to meet a minimum airtightness of 0.6 air changes per hour. And that contrasts with 1.5 air changes per hour would be an R2000 house. And of course, we don't do blower door tests for every code-built house in the country, but the expectation is that most of those houses are around a 3 or a 4 air changes per hour. Many could be worse. So we make the building very airtight, and we install continuous insulation that is super, says continuous on this slide, but it's also super insulated in that the values of insulation are significantly higher than what we would have in a code minimum home. And we designed the building to be thermal bridge free, meaning we don't have any spots in the building envelope where materials that are highly conductive can bring the cold into the inside from the outside. And finally, when we have a building that's that tight, we need to make sure that people have healthy, fresh air. And so we do that with a ventilation system that has heat recovery, so that we're not wasting any heat from the exhaust air. So we put in an exceptional HRV, and a new build house would have that as well, but it wouldn't be as high performance as the ones that are needed to meet the passive house standard. So those are all of the sort of technical targets or principles that we're working with when we're designing a passive house.
And not sure if everybody knows what the term biophilia means, which is one of our guiding principles. But basically, as humans, we have an urge to connect with other forms of life, and this includes nature's. So studies show that this is important for mental health. And ways that we do this is by creating spaces that connect closely with nature, by having views and inside-outside connection, views to trees and plants and things like that. but also by evoking nature, by having things that have nature-like forms.
And so when we talk about design for the senses, it's really, you know, a reaction or a background in thinking about our environment, not just about the visual. And so we're working in, and of course, we're going to show you a lot of pretty pictures during this presentation, but the space and your experience of space really influences how you feel and how you behave and how you think. And that is about, you know, the visuals actually probably less important than the other senses in the way that they impact your health, your comfort, your happiness. And so if you think about qualities of spaces that you've been in that have had amazing sound or quiet, about the way that light moves in a space, and also shadow. So there are differing moods and differing feelings that you have in these experiences. And then the materials that we surround ourselves with and their tactile qualities also evoke different senses in us. So if it's rough boards, or if it's a smooth metal, and you know, you've probably encountered a stairway where, you know, it was irresistible to hold your hand as you walked up the stair along the handrail because it was, you know, ergonomically pleasant. And then even smell is, you know, when you talk about when real estates talk about selling a house, you know, they're always kind of baking cookies or loaf of bread to help them with the sale. Our sense of smell is actually one of our sort of most primitive senses that evokes very, very old memories in us. So cooking smells from childhood, you know, some recipe your mother made when you were small can bring you back to a place that you're, you know, that is not always present in your day-to-day mind. And we have this image of fire here because fire is something that almost universally people are drawn to. It evokes all of those sensory feelings. You feel warm, you have a play of dynamic light and shadow. It has a smell, it has a sound. And so that sort of primitive human instinct for fire is one of the senses that is hardest for us to ask people to get rid of in a passive house, because you know, you've probably heard that passive houses shouldn't have fire, and so that's something we might talk about later. And so before we launch into the part where we start showing you some of our projects, I'm going to invite you to think about a time when you felt most at home, where, you know, it might be somewhere you were on vacation, it may be somebody else's home. This is a question that we ask our clients at the beginning of projects in order to design houses for people that nurture their senses and that are as comfortable as they possibly can be for that particular person. We really need to get to know them and to ask these kinds of questions. So what kinds of materials make you feel great? What quality of light makes you comfortable? So as we go through this, if you might think about these things, maybe you can let us know at the end, because we're always researching this.
Great. So I'm going to start by walking you through our approach to designing new homes. And the example that I will be using is called Two Rocks Residence, and it's located in the Gaspereau Valley. The owners are a couple with 2 young kids, and they actually just moved in early this winter. I think it was February of 2021. So they've had the winter there. And the property, as I said, is located in the Gaspereau Valley. It's on a hill. It overlooks Blomidon, Cape Blomidon, and the vineyards to the north. And that it has the forest really closely right behind it to the south. And it's a beautiful property. They have a hobby farm, and the woman is very interested in pickling and creating preserves in her own food. This little slideshow that you see of Two Rocks tells you how we go about incorporating our design approach to Two Rocks. And first of all, it is a net zero solar array project. So there's our solar panels on the roof, and we have the passive principles like solar gains. We have daylighting of interior spaces. We use shading devices, natural cooling from mature trees, and there's cross ventilation through the windows that can open. We also, as Lori mentioned, make use of efficient mechanical systems. And in this case, we use the heat recovery ventilation and air source heat pumps. And the biophilic design principles in this case came from both the views to the outside, the connection with nature, as well as the use of natural material, both inside and outside, and trying to take advantage of daylighting as much as possible. And in passive houses, we try to get a very durable envelope by creating walls that are super insulated. And we have really high efficient windows and doors. They're airtight and there's no leaking, and the materials are generally robust materials. And what we see as the advantages of passive house approach is that it can basically give you the best environment for occupant comfort. The thermal environment, it's really kind of like quite a lovely constant temperature. There's not much fluctuation in temperature. The indoor air quality is exceptional, and it's generally a quiet home. You also get significantly lower operating costs due to the reduced energy consumption. And you minimize your mechanical system costs because you just don't end up needing as much of it. And so over time, you save in equipment and services and replacement. And it's resilient with power outages because it permits a smaller generator. And you focus on generally on energy conservation, and then you supplement with appropriate renewables. I'm not going to get too much into the floor plans. I just wanted to give you guys a sense of the shape of the building and describe it a little bit. So this is the main floor plan of Two Rocks, and generally there's a public wing to the left of your screen and a private wing to the right, to the west. And these wings are connected by an entryway. And in the public wing, that's where we have our living room, dining room, kitchen. They're all visually connected, and they are focused to the view on the north. And the main bedroom is sort of very much connected to the forest. Underneath the public wing, there is a basement, which has a games room, a TV area, the guest bedroom and bathrooms. And then on the same public wing, there's a loft on top of the on top of the main floor that has a library, a yoga space, and a studio. This image shows, again, what we call our partie. So we typically like to start our design with a concept. And this is how the Two Rocks concept came about. The idea of, the Gaspereau River with, two rocks, one orientated towards the view on the north, where Cape Blomidon is, and the other one very much focused to the view on the tree site, and where they can sort of engage the different views of nature in that way. This slide shows how we energy model. So one thing about having a passive house is that there is a big difference between a conventional house, in the sense that we have to do an energy model. And with a conventional house, you're basically guessing at whether your house will be comfortable or not. Whatever it lacks in comfort, then you supplement with turning up the heat or opening a window or putting in air conditioning. Whereas with an energy model, you can actually very accurately predict what your comfort level is going to be. And in many ways, the energy model explains to us how to do a passive house. And one example, for example, is in this Two Rocks project, because our building is very much about the views, and our view in this case was to the north, we looked at the energy model, and the little graph that you guys see on the right shows to you two things. It shows the transmission losses that we get. So when you get, energy losses through your windows, and the green represents the energy gain. And what you can see is that on each side of the house, depending on where you get sun or you don't get sun, and on the north, as you all know, typically the sun doesn't shine in. So we ended up having more energy losses than we had gains. And this was because of the big window that we needed to look at that view. And with the energy model, we were able to exactly calculate whether it was worth it to keep that window or not. Lori did actually the calculation, and we sort of speculated, well, what would happen if we did get rid of that window, or get rid of such a big window? How much would we save? Is it worth it, this window? And the conclusion was that you would save about $22 a year in energy consumption, and which made us realize that really, who would want to give up this view and so that you would save $22. So we decided that it was worth keeping it. And the entire house was designed around the views. And so, this was an important thing to look at. And passive house, we basically see it as it's a tool that can get you the best house possible. And of course, what are energy models if it's not for giving you good numbers to work with? Our clients received their report from their evaluator about energy savings. And what you can see here is there's a house comparison chart on the right that shows a house that was built to code and how much they would be expected to spend, both from a fuel cost as well as greenhouse emissions and things like that. And the house that was built to code would had to pay about $6,098, a house of this size, in energy costs. And our clients ended up getting back $1,150. So their annual saving by going this way with passive house and a solar array was $7,250 almost. And best of all, they basically saved 28.4 tons per year on annual greenhouse gas emissions. I'll let Lori. Lori, you want to take this slide?
Yeah. Sorry, this is a very vague slide, but I just actually threw it in from another presentation. I think I should take a little step back, because when I explained passive house, I probably should have talked a little bit about why. So Harvey had a question in the chat about, why. And so passive house was developed as a way to use science, meaning using physics and economics to build the best house possible. And so I wanted to put this slide in just so that I remembered to tell you guys about the economics. This isn't from the Two Rocks house. This is from a different, a study of a different passive house that we built, that we were fortunate enough to be to have an independent economic case study done on it by a company that does what is called total cost of building ownership. And so the green line that you see represents the expenditure by the owners in both maintaining the house and in heating and cooling the house in question over, it's a long timeline, over 60 years. And the pinkish red line represents the same house if it was built with code compliant specifications. And so you can see with that over the first few years of owning this house, oh, and this, I apologize, this isn't the expenses, this is the equity. So it's the expenses and also the value of the property over that 60 years. And so the passive house had more equity right from the start, as a slightly more expensive building. And over time, it became more valuable. Whereas the code compliant house, kind of the arc of this graph is similar up until about the time the house is 20 years old. And then you can see that after that, the code compliant house goes downhill. And what this means, because I'm describing it, I'm taking a long time to describe it, but essentially it's showing that your investment in energy efficiency, which is the sort of primary reason that people invest in passive houses, combined with the investment in having less maintenance, less servicing, less replacing of mechanical components over time, that the passive house is obviously always going to be on an upward trajectory or an even stable trajectory. And after a code compliant house is about 30 years old, it's a money loser. You're going to be throwing more and more money at it. And so, the background of physics and economics to make the most energy efficient house possible, make the most comfortable house possible, and the most healthy house possible panned out in this case. And I think we could talk about it more after we, at the end, if people want to know more about the economic side of it.
Great, thanks, Lori. So back to the Two Rocks project. I'm just going to take you guys through a quick tour of the interior so that you get a sense of how we express the connection to nature that way. This is the entry, that breezeway connecting the public and the private wing. And one thing we like to use is to have a consistent palette, both on the inside and the outside. And in this case, our cladding has accents of both pine and charred pine, which adds that textural element. And on the inside, we reflect that in the colors as well, the black and the natural material palette, different textures, different types of materials, like the raw metals of the beams and railings, and pine and spruce structural loft ceilings and beams. And even though this mudroom, which you're seeing on the right, and the kitchen on the left are not in the same room, again, it's a consistent material. And the honeycomb tiles that you see in the mudroom floor do that evocation of nature, where they remind you of, honeycombs. Another thing we did in this case was that the basement is very much an anchoring space for the clients, for the homeowners. So we wanted to give it that kind of like that effect of being a moodier and a bit of a darker space to hang out in. But we wanted to make sure that at the same time, there was still access to natural light. And in contrast, the upstairs, the loft space is the brightest and the lightest space, where the materials are even more able to reflect light and contrast the basement. This basically shows a view of all the different materials coming together: the raw metal, the rough wood, and slate tile for the fireplace, and wood flooring. This is a further back view of the same room, which shows the connection between the different spaces and how deep the windowsills are in a passive house. Same goes for the main bedroom. Again, we wanted to evoke a certain coziness, which we did with the use of darker color, and at the same time have natural materials like the headboard. The whole wall along that back is made out of plywood, and we're trying to bring nature in by having as many windows as possible, in this case both facing south and facing west. This is the bedroom that's connected to the forest. Like, you wake up in the morning and the forest is right there. In this case, we have the main ensuite. And again, even in here, we're bringing in as many natural materials as possible. Our shower has a window in it, so you can look outside while you shower. It's a fairly private location, so they have the luxury to do that. Showers and the spaces are big enough that you can actually even bring indoor plants, like large plants, to bring nature right in. The photo that you see on the right is actually the same window. It's the other angle side of the window during construction. So again, it gives you a sense of how these, large windows are kind of put into the envelope and into the wall, and all the strapping and work that is involved.
Judy, before we go into renovations, Harvey had a couple of questions. So maybe could you flip back to the slide that shows the room with the fireplace?
Yes.
So we have in either picture. So that fireplace is in the room, in the living room with the big tall windows. And so with an airtight, with a house that is as airtight as a passive house, it's challenging to install fireplaces. But we've done a fireplace in almost every passive house we've done, and it's because homeowners want them. They want that psychological ability to sit beside a fire. And so what we do, we always source a very low BTU fireplace. So meaning something that, in Canada, it's challenging to get them, but because most people want their wood stoves to put out as much heat as possible, or their fireplaces. But what we do is we research and try to find one with minimal heat output, so that we don't cook the people that live in the house. But this is a very big room. This room has a lot of volume, and it is the room with the north window. So when the clients came to us, the owners of this property, the fun, right at the top of their priority list was giant north window looking at Blomidon and a fireplace. And we didn't promise them that they could have either of those things, but we set out with the energy model and assessed it. And it's not a, we start the energy model right at the beginning of the project. As soon as we have the drawing that or a diagram that looks kind of like the one Judy showed you with the two boxes and the wiggle between them. We start at that stage doing the energy model to see what the performance of this building is going to be. And essentially, we did find that window is going to make them uncomfortable. So they're going to experience discomfort if they're sitting near those big north windows on the coldest days of the year. It's not going to be much of the time, but it will be. And so we're offsetting that by having this fireplace in that space. The fireplace, this fireplace is not the original fireplace that we spec'd. These owners, as you can gather, this is a very fancy house, and they were willing to source the right products for the house far away if they needed to. And so the windows are from Poland. A lot of the wood and both the structural lumber and the cladding is local. Yes, Veta. They're from Veta. So we've got like many things that are very local. The pine that was sourced is from, something like 10 kilometers away. But we had ordered a masonry heater fireplace from another, I think it was from Czechoslovakia. And it was a mass heater that was designed to have, it had all kinds of channels running through, so that behind the tile that you see, there would be a series of channels that would contain the heat and release it really slowly, so that they wouldn't experience like a great big period of overheating. And that beautiful fireplace arrived in Nova Scotia in a shipping can that had gotten smashed to smithereens. And so we needed to substitute a different one. So this isn't our first choice fireplace, but I don't think they're cooking. I don't think they've had, it's not a fireplace they're going to use every single day, all day, like some people use their wood stoves. The other reason they wanted a fireplace, aside from atmosphere, is that there's something like 30 acres of forest that they'll be maintaining over the rest of their lives on this land. And so they have fuel right there to feed it. Yeah.
Great.
And you can ask me more questions about the fireplace after if you want.
Can I go ahead and move to your?
Yeah, well, yes, we'll go to yeah.
The renovations.
So, yeah, so I'm going to talk about renovations. So it's funny, Judy and I, we did so many renovations. We did, over the years, we did something like 80 or 85% renovations. And every once in a while we would get a new build, but we've definitely paid our dues in terms of renovations. And the thing about renovations is they're really expensive. They're always custom. You really have to, kind of reinvent the wheel all the time, and they're risky. So approaching a renovation with layering in sustainability requirements is extra challenging. So meeting high performance targets on a new build is a lot easier than on a renovation. So yeah, every renovation is custom. It starts out with a deep study of the house, with measuring every inch of a house, with drafting it in 3 dimensions, with obtaining any fuel or electrical bills that the owners are able to share with you, and doing a preliminary audit to understand what exactly the conditions are in terms of air leakage. So it really is like detective work. And so we do this detective work on a new build, but it's much simpler because we're understanding topography and where the sun is coming from. But with a renovation, we need to layer on everything to do with the existing conditions. You can jump. So I'm just going to talk about a couple of renovations, kind of common things that happen. One of the things that almost every project, the people who are the homeowners are asking for more sunlight. Their houses are too dark. And so this is one where it's a townhouse where the owner lived on the north side of the townhouse. And so their entire south wall was shared, and they had very, very little opportunity for daylight. And you can see we didn't touch, this is about a sort of 1870s or 80s era house in Halifax. And we didn't really touch the two front rooms, which are the dining room and living room, but we completely reconfigured the back end of the house where the kitchen was. And this kitchen and bathroom at the back, so the kind of back bump part of this house, there was no insulation, but there was also no heat source in this house. So they were coming to us asking for sunlight, and we said to them, you need a lot more than sunlight. So the project was quite a bit more expensive than they were hoping for, because they basically just wanted, maybe you can jump to the next slide, Judy. They just wanted this big door. They were like, can we have a great big door at the whole back end of the house? And we gave them that door, and you can see it. So this is a west facing garden door. The concern with this is that is overheating. So in Nova Scotia, well, in Canada, really, we always get solar gains from the south, and we always kind of lose energy from the north, and to a smaller extent the east. But we frequently experience overheating from the west because the sun is lower in the sky, and because there's more heat in the western sky sun. So it was a concern to put this door here, but they have a massive, you can only just kind of see it, there's a massive cherry tree in the backyard of this house. And so it was a little bit experimental in that I think on the hottest days of the summer, they are a little bit warm, but they can also open that door. So it's a 12-foot wide door that opens in the middle. In the course of doing this work, we insulated the whole back of the house. We put in-floor heat in the slab. It's not a slab, it's actually, there is a basement in this part of the house. So we put in-floor heating, radiant in-floor heat. And we put, one of the things that we need to worry about with old houses and adding insulation and the building science is what happens with with vapor in the walls. And so we used a smart vapor barrier. So a vapor barrier that if any moisture gets in the walls could be could release to the inside and prevent any moisture buildup inside that wall assembly over time. So that's what we did on this house. Another thing that happens, that really one of the big things that makes renovation work, sustainable or not sustainable renovation work really risky, is that you just don't know what is happening inside the building assemblies until demolition starts. So you might be working on the design for maybe 6 months before finding out that you have a lot more problems than you expected. So this is a project that we just photographed this summer. Yeah, and you can see that and I included the before picture of this. So this is a bathroom, and the bathroom that was there wasn't that bad. It was actually a house that our clients purchased from someone who had flipped it, and they had done quite a few quite pretty things to the house, but it just wasn't quite nice enough, and the layout wasn't great. So the clients, we had lots of discussions with them about just what we were going to do, like what parts of the flipped renovation should we save. And they felt a bit guilty about ripping up this bathroom. And then we ripped up the bathroom, and we found that probably if they hadn't done it, they were going to have some very serious structural issues in future. So yeah, this isn't really so much about a sustainability problem so much as just an inherent problem to retrofits, but it's something that we always have to have in mind.
Oh, whoops, sorry.
Oh, that's okay. So now we're going to talk about this project in a little bit more detail. We're calling this one Magnolia. This is a lake house on Chocolate Lake in Halifax, or just on the other side of the peninsula. And it's a 1950s era house that had just very, very strange series of renovation done to it in maybe the 1980s or 90s. And it again was, we started working with the owners right after they purchased it. So they purchased it with the intent to do a renovation. And primarily the renovation, what was driving the renovation was functionality. And really, that's the primary driver in a lot of our renovation projects. So people will want to do their renovations because their house is just not working for them. But in the course of doing, improving the layout and improving the aesthetics, we always manage to sneak some, or in some cases, lots of sustainability measures into the project. So in this case, you can see we managed to put, we put in on lots of solar panels. Yeah, so the cladding here, it is wood siding. It's locally produced wood clapboards and vertical boards from a company called Cape Cod. It's wood siding, so in terms of longevity, it will have some maintenance, but it's obviously a low carbon material. It's made in Nova Scotia and it's durable. The owners really, really wanted to do a metal roof, but again, for longevity and durability, but in the end, the budget kind of made them cut the upper metal roof. We do still have the metal accents on the lower roof. Maybe, oh, and I guess one of the things though on this house, see, this is the south wall of the house. And one of the things that these clients asked us for, partly because the house was just so badly laid out that they were really worried about storage. And so they had asked us to put a garage in the driveway, or to put a garage on this side of the house. And that would have required cutting down that beautiful magnolia tree, which we've named the project for. And it would have really reduced all of their natural access to natural light on the main level of the house. And so we did kind of a series of solar studies where we modeled the house in 3D and showed them the shading analysis and basically talked them out of it. And if you were to meet these owners today, they would tell you how grateful they are that we talked them out of it. It's almost the first thing that they mention most of the time when they tell people about the house. So yeah, jump to the next one. So here's what we did on the house. So similarly, our approach to all of our projects is fairly similar, whether it's a renovation or a new build. So we always incorporate biophilic elements. It's psychologically, we just can't imagine not promoting and enhancing people's connection to nature. We're very fortunate. We're showing you like projects that we've been fortunate to work on that had just absolutely gorgeous settings. So in this house, and I think you'll see in the photos as we go through it, it's a lake house, but like you barely could tell from the inside. Like there were almost, it was a very kind of navel gazing house where there was only kind of one room where you looked at the lake and it wasn't even a very big room. So our biophilic principles are here. In terms of envelope, and yeah, somebody in the chat was asking about sustainable harvesting in Nova Scotia, and that's something that I'm not going to say that my head's in the sand. Like I feel like I wish I knew more. Like I am pretty pessimistic at times about Nova Scotia and forestry, but I guess I would rather wood that's grown in Nova Scotia be on one of our houses than be turned into toilet paper or burned for electricity. Don't want to get too political, but yeah, it is something that we actually tend to use a different cladding company, but this I might even be wrong. I'm pretty sure this is Cape Cod, right, Judy?
Yes, it is in this case.
Yeah, okay. We often use a company called Maybec out of Quebec, which is, I feel a little bit better about their keeping track of their wood provenance. So the envelope upgrades on this house, we had new insulation, new windows and doors, and durable wood cladding. But this is the big elephant in the room. The new insulation was spray foam, and this happens to us more times than I care to admit, that we specify not spray foam. We'll specify cellulose insulation or bad insulation, and the builder will substitute. They'll talk the homeowners into it. They'll, builders all want. I shouldn't generalize, but many builders like the the sort of one step of achieving airtightness and insulation with spray foam. It's very easy. But spray foam has...
Oh yeah, sorry. I was just going to say if you could elaborate why cellulose is better than spray foam.
Yeah, so spray foam has one of the highest embodied carbon amounts of any kind of insulation. So essentially closed cell spray foam and XPS insulation as well are very, very bad in terms of greenhouse gas emissions in their production. And so we really, as a rule, we work on every project to tell the builder, we do not want spray foam in this project. The reason, there's one other reason that they want to use spray foam, and that's because when we're working particularly on sort of 1950s, 1960s houses that might be built, they may be built with quite shallow structures, so they may have 2x4s. We can't get code compliant insulation, R values in a 2x4 wall unless you're using spray foam. And so options are to add extra insulation on the outside of the house underneath, to increase that R value. You would either put a layer, kind of like a blanket on the house under the new cladding, or the building inspector will make them fur out the walls and make them fatter, and they don't want to do that. The builders sort of resist that, and so anyway, I'm going on a lot about it, but it's pretty frustrating because we'll have the homeowner convinced, and then at some point there's like a slip of the hand happens during construction, and we show up and find out that the contractor has changed the homeowner's mind. That's something we're working on, and so cellulose insulation is our preference, but it's because it's made out of recycled newsprint, and so it's very, very low carbon. It actually locks carbon kind of stored in the building. It prevents it from decaying by having it inside your walls. But the R value per inch isn't as high. So even if you were to use bad insulation, which has, sort of regular pink fiberglass, it has an embodied carbon cost, but it's nowhere close to, where spray foam and other foam-based plastics like XPS are on the embodied carbon spectrum. And until people start measuring that more, it's just sort of starting to be something that the building industry is talking about quantifying in a meaningful way. We've quantified it on a few projects, and we'll continue to do so, and hopefully try to keep keep persuading clients to go the low carbon route. So other things we've done in this house, so we did use, this isn't a passive house renovation, but it is, a sustainable renovation. We made use of passive principles, including making use of solar gains, and also, benefiting from the daylight, but also making use of a little bit of shading devices. So kind of the little angles over the door and that sort of thing. There's also a lot of mature trees on this site, and just designing the house for cross ventilation and for cooling from vegetation has a huge impact on interior comfort. So that the wind blowing through a tree before coming in, the air coming in your window has a cooling impact. The house is significantly more airtight, so we made sure that it had an efficient ventilation system, and we also replaced their oil-fired furnace with air source heat pumps. So it has a very efficient heating system now, and that really is the first step in any project. It should be your first move in a new build, and your first move in a renovation is to get rid of anything that has fossil fuel. So electrify all your building systems. Even though Nova Scotia does not currently have a green grid, our grid is going to be green. And if you're building a new house and you're putting a new heating system in it, it should not be something that locks the owner into burning fuel oil or propane for 15 plus years. So that's number one rule, is electricity. And then after that, or maybe side by side with that, we invest in envelope improvements when it's a renovation. So this part is always the part where we are doing sort of cost benefit analysis, because we almost always want to add insulation and improve the windows and doors, but it's where it's not so much the materials as the most labor goes into the retrofit. And often the homeowners, they obviously care about having homes that are comfortable and energy efficient, but there end up being conversations about what is the priority, prioritizing this performance over prettiness. And I think that that's one of the reasons why we work so hard to make our sustainable projects pretty, because we want people to know that they don't have to compromise on the aesthetics to have a nice home. And then lastly, and I skipped healthy air, but yes, if we've upgraded the envelope, we always need to make sure that we haven't made it so that air is, we're cutting air changes from the envelope, but at the same time, you don't want air changes through the envelope to be what people are breathing. And so we want to make sure that we have a heat recovery ventilation system that brings in fresh air without making people cold. And then finally, we add renewables if it's appropriate. And meaning, in some cases, on a renovation, we don't have the orientation. In some cases, we might have the right orientation, but there's big mature trees. And I'm never going to tell you to cut down a 100-year-old tree for solar panels. The value of the tree is priceless in my view. Oh, and I just lost my final point. So, yeah. So then, the other thing is the functional upgrades. Like every project includes functional upgrades. And these are the things that make people's lives easier, make their daily habits and patterns work better for them. And so that is a sustainability measure. If the moves that we're making with layout changes mean that somebody doesn't want to move out of that house and they invest in it and stay there for a really long time, that means that they're not going to be buying a new house or renovating a new house. So doing a great job of a renovation and doing a thorough job and really thoughtfully planning the ways that people are going to use it mean that the next person, even when they sell it, will be less likely to kind of do another complete overhaul and send a bunch of stuff to the landfill. Do you want to jump forward, Judy? So in this house, just so quickly go through the before and after. So this is the basement, and I see there were some questions that Judy was answering about the basements. So this house, we believe, had a basement renovation that was the consequence of an oil spill, but they only partially remediated the space. So it was a really weird space where you would walk down the stairs and then you turn right and you go through this sort of tunnel-like space, and then you turn right again, and then you could turn right or left, and then you turn right again, and then right again, and then right again. And this middle part of the house was there's a few steps showing on this plan, but it was like you would step up and then you would step down and you would step up too, and the ceiling height was like under 7 feet in most of it, and so it was just a nightmare. Very big labyrinth. And so we did two things. Well, we kind of opened it all up, but we also lifted this house. So the main floor was elevated off of the basement by about 2 feet. And so that facilitated getting more, more daylight into the upper levels and more headroom and making this space functional. Want to jump forward, Judy? Yeah. And so that's what the basement looks like. They're using it as kind of rec room, gym. They have it as, so this is a family with 2 teenagers. Everybody's very fit. They swim in the lake every day. They skate on the lake in winter. They're coming and going from the lake through this basement all the time. And they're also using it as a fitness space. And just kind of around the, where the photographer's standing, there's also kind of a TV watching area. And the main level, we moved their kitchen. So you can see it's kind of divided in the original house in, there was a kind of long, skinny sunroom, and then the kitchen in the middle of the house, and then a couple of, they were kind of used both as living rooms, but I'm assuming that one was the dining room. So the room that is behind the kitchen was actually set up as a living room. And then the dining room was the long, skinny room on the end. And really, those rooms were quite inward focused. They weren't taking advantage of the lake views at all. And so what we did is really, we opened it all up. We added a small addition on the front. And that we were forced to add that addition because we needed to, we replaced the stairs, which were excessively steep. And we we had to make the new stairs to code, and we didn't have enough space in the building. So actually that front bump was literally forced upon us by making a code compliant second floor stair. And so we've got a very open concept main level of the house now. And I think we have a couple of pictures. So this picture, the people who were here aren't hoarders. We were actually measuring and photographing the house at the same week that the people who were moving out were packing. So there's packing going on here. And so this is the kind of long, skinny room where you could kind of just sit a row of chairs to look out at the lake, but there really wasn't a way of gathering and enjoying the view there. And then on the other side of that opening was, no, that's okay. And then, you know, standing in the kitchen, really, if you were doing dishes, you could look out at the lake, but that was the primary spot in the main part of the house where you would have a lake view. And so, yeah, now you can jump. And so the owners, our client said, we want to see the lake from every room of this house. And we pretty much were able to do it. And so we really love these views that just show the angles of the lake that they're getting. And then upstairs was the strangest of all. There were 3 bedrooms, and then the 4th bedroom you actually accessed through another bedroom. And it was very, very low, kind of almost dollhousey dormer kind of ceilings, and quite hard to live in. So several of these bedrooms could only fit like the 2 bedrooms where you walk one to the other could really only fit a twin bed. So they were quite awkward and not functional at all for a family. And so we popped that roof off entirely and just kind of made it simpler and cleaner. And we actually turned the dollhouse end of the house into the primary bedroom. And it's almost like a tree house sleeping in that bedroom now, and really reorganized the rest of that level as well. And so that's the sort of before and after of the stairwell, just significantly brighter. And this is the main bedroom. And I don't always do this, but when we photographed the house, I actually crawled into the bed to see what it would be like to wake up in that room. And it seems pretty awesome. And finally, we're turning the tables on ourselves. So I think it's a week from today, Judy and I close on the purchase of a building that we bought to be Habit Studio's new home. And now we're kind of sweating because the pressure is on for us to do our own sustainable retrofit. We're our own clients. We're arguing with each other about moving a door. Anyway, so this is 150. Is it 150? It's from the 1850s. So yeah.
1850s.
1850s era Halifax house in the North End. And it's a pretty hard, I should have cropped that photo a little better so that you could see that on one side it has a party wall. So there's a stone party wall, sort of floor to basement all the way up to the roof. And on the other side, the foundation has been stabilized at some point, but our other side wall is at 100% lot coverage, meaning if we make that wall fatter, we've got about like 3 inches that maybe we could add insulation on that wall. And we can't really add insulation on the inside because that's where the stairs are. So we've got ourselves a puzzle. So what we're planning, and this is probably going to evolve, we haven't spent we spent a lot of time thinking about this project, but we haven't actually spent a lot of time in the house yet because it's not ours yet. But the current plan is that we're going to give this poor house that has no insulation, we're gonna blow in cellulose insulation, and that's not going to do, it's not going to get us anywhere close to passive house, but it's going to be a low carbon solution to initially insulating the building. I think it might get us to maybe our, I don't know, maybe our 10. And then we're going to, that picture of the mist is aero barrier. So aero barrier is an aerosolized it's kind of latex. It's almost like aerosolized caulking. And so we're going to use aero barrier to bring up the air tightness of the building. So the first thing we'll do is get a blower door test done to see where we are. I imagine we're at something like 20 some air changes per hour in this building. And so air sealing is going to be considerably more impactful in making us comfortable and in reducing the energy bills than insulation will. But of course, we need both. And so the way that they apply air barrier is they put a blower door up and they set up a little tripod, and then they emit the mist, and it fills up all of the air gaps that are basically anything like smaller than a quarter. We're going to keep and fix the existing plaster. So there's a few places where it may have to come down just because it's in quite poor shape, but this house has most of its original plaster, and we're not going to go in and gut it because it'll be beautiful, and because we just don't want to send it to the landfill. And hopefully we make it so airtight that it's needed, but even if it isn't, we're going to be adding ventilation. And so that picture of the sort of disconnected series of rings, that's what's called a through wall HRV. And so rather than install a number of ducts in this building that doesn't have ducts now, we will be probably installing one or two of those maybe in the stairwell. And so unlike a ducted HRV, these are one directional ventilators where it will actually run for about 30 seconds blowing into the building and then 30 seconds blowing out. And the core, it has a ceramic core, and that core kind of strips the heat out of the exhaust air so that we're not wasting heat. So we'll be tightening up our envelope. We will be adding an HRV. This building is already all electric because the previous owners took out hot water rads some time ago, but it's all electric baseboards. And so we're planning to add an air source heat pump. And hoping that we can add an air source heat pump and just create like a small chase and have it be a ducted one, that rather than having an ugly heat pump on the wall, but we're not really sure about that yet. And then finally, we're going to replace the windows. And then the cladding is not in bad shape, but ultimately we may do external insulation to bump that value up, in a couple of years and replace the siding. It's a stone foundation. I didn't include any basement pictures because I didn't have any great ones, but it's a beautiful stone foundation, and that's our final. That's the one thing I really haven't wrapped my head around yet is how are we going to address the basement? I don't want to spray foam it, but we're going to freeze if we don't either insulate the walls or insulate the floor. So that's the puzzle that's going to be sorted out soon. And that's it. I feel like we've gone, well, we went way over time. So how many questions? I'm like trying to keep up with
I've been
the
trying
chat,
to answer them as
yeah.
they go along, but
And I'm sorry, I thought we were like going to be way faster than going over time.
No, that was great. It was really good. How are you, Lori and Judy? How are you doing for time? Were you okay to stick around for a couple more questions?
yeah,
I
sure.
am, 10 steps from my bed. I don't have to go anywhere.
All right, yeah. I think I'll kick us off here. I was wondering if you could talk a bit about sort of any changes that you might have seen in regard to sustainable practices
Yeah.
in your industry. Have you seen more interest among clients or even architecture students in like passive
Both.
home design or
Yeah. So I became a certified passive house designer in like 2013, 14. And I did it because a client asked me, they were like, we want a passive house and we want to work with you. And so then that was kind of how I started. And then of course, once I knew about passive house, that's all I wanted to do, but nobody else, I would kind of be like, hey, have you heard about passive house? And they'd be like, yeah, that sounds expensive. They really weren't too into it. It took a few years, and then our then we did a couple. We were fortunate enough, clients found us, but I don't remember, and maybe you remember, Judy, but at some point we said we had done a few and we were just like, it just felt wrong to build a new build that wasn't passive. It only has to be about we have a passive house in PEI that is like the same cost as a code built house. If you make the right decisions, it doesn't have to cost more. And so knowing that, it's really painful to put resources into something that's just a regular house. So we made a decision. We started telling people we wouldn't do their new houses unless they were passive, and that kind of worked. Which is funny. But now what happens is people are asking for it. Like used to be, we would say the words passive house first, and now people are coming to us because that is what they want. And that's just happened over, I would say, the last 2 years. But it feels pretty good.
Yeah, we have another question in the chat here from Brendan. It says, do you always put the windows on the exterior of the assembly? Thoughts on putting them midway in the wall?
There is an energy there's a little bit of a hit in terms of performance if we put them where we put them on the outer part of the wall. Meaning where we locate them, like in terms of the physics and the heat losses, having it kind of in the middle of the insulation is the best. Putting it in the very outer part of the wall is what we do on we only have one project, maybe two, where we didn't do that. And we do it because anybody who was here yesterday would know why we do it. Like the way that we experience rain in the Maritimes, it's like we're just so vulnerable to the impacts of driving rain. And so to detail the window on the outside of the wall in kind of the more or less conventional way that we do regular houses makes a lot of sense in terms of keeping the water out. It's a trickier installation to have it in the middle, and it's more likely to leak. And also people really like deep windowsills on the inside. So aesthetically, so it is a like performance compromise that we choose to make most of the time.
Great. Is there anybody else? You can jump in on the audio too.
Yeah, sorry, I'm overwhelmed by all the questions. There's like,
yeah.
Let's see. Judy, have you been keeping track? Is there like a...
Yes, I've tried to answer as much as possible. Okay. I think, it was just the window one that I had not yet. Yeah.
There's a question about difficulty and about upgrading an old HRV. So an HRV from 1993 is not going to be close to as efficient as if you were to do one today. So your HRV is it's a unit, and then you have a bunch of ducts. So changing out the actual HRV would probably be quite beneficial for a 2021 model. And you would clean out the ducts, keep the ducts, and replace that HRV. I think it would be totally worth your while. Any others? Harvey, you had a lot of questions, and I don't know if we got them all. I was like, oh.
I'm sorry. I
No,
really
it's okay. I love them. I love them.
I enjoy, I guess, well, for some people, I'm a Passive House certified tradesperson, and I've seen Lori's presentation a number of times on Passive House Accelerator and the Tech 3. So it's always good to see her and hear what she has to say. I've run in, and I'm based in Toronto and in Ontario. I had someone call me and ask me what do I think about Passive House, and then they told me, well, we're talking to Lori, and she and her partner are going to be putting up our plans for us. So you guys have done great today by having both Julianne and Lori here, and I appreciate just to me, it's like a refresher a little bit when we're going through it. I have some issues I'm doing right now with that I can get into some really, really heavy questions and details, but I don't think it's the forum for it, but we can always have that quick conversation. But I think the main one, you talked a little bit about energy efficiency, and I'm happy you did. And that sort of is a big driver of this, and especially for the people who are on here who are a lot younger than the principals who are talking, and me specifically. So I think that's one of the things that's a big driver for Passive House, and the carbon, obviously. The only other question I really had is that you talked about durability, which is a really big. Comfort is very big, which you did talk about. But can we just talk a little bit about drying? Because I think that people don't seem to grasp that concept, and that's one of the hardest concepts that everybody, when they look at it with, stealing from our friends at down south, the obsolete home being conventional, the difference between the two, between Passive House and a conventional when it comes to drying. Thanks, guys.
So I guess I would start out with just saying, here's a really funny thing. If you do moisture testing on your building, so say you build a house or any other kind of building, and you install some sensors in the wall that monitor the moisture in the wood, in the assembly, in the insulation, and model that. It's called hygrothermal modeling, where you would do kind of, or it's not called hygrothermal, it's anyway, hygrothermal sensors, and you test that. It's going to actually be wetter after, so you build it, you're going to have a moisture. A house actually gets wetter for a couple of years before it actually starts to dry out. Nobody would ever guess that, but this is just the sort of, it's just going through some cycles, wood gets dry, weather patterns happen. So that's number one thing that you should know. We have, and I mean, in the Maritimes, I think pretty much everybody just feels it, and Southern Ontario too, temperature fluctuations and humidity fluctuations cause vapor drive through our buildings. And so we have, in different seasons, moisture is moving through the walls of a building, and the direction, it kind of changes direction. So in the summertime, you would have humidity in the building, but you got the windows open, it's not such a big deal. In the wintertime, you close everything up and you're cooking and showering and whatever, bodies are emitting moisture. You're breathing, you're breathing when you're asleep. And all of that, if you don't have a ventilation system, is actually going to want to just move through your wall. So moisture moves from sort of the area of higher humidity to the area of lower humidity. So it's just going to gradually work through the walls. And that's why in our building assemblies, we usually have what we call a vapor retarder. the thing that can happen when you're building really, really fat walls, like a passive house, like if it's, say, like I think Judy was telling you some of our, wall details that could be like a wall could be 20 inches thick or something. And that can hold a lot of moisture. If your wall in your sort of regular house, like I live in a 1920s house that has the skinniest stud ever, my walls are like 3 inches thick or something. If there's moisture in that wall, I'm going to know it the next day. But when you have a 20-inch thick wall, that wall could just be absorbing moisture until you have like a horrific mold issue or just water issue. And so it is really important to design your buildings and to detail them in the construction process so that really we need to stop air from moving through, because most of the moisture that gets into our walls is just carried on the air. It's like, so we have a air barrier that stops the air, and we also have a vapor barrier, and the vapor barrier isn't quite as important, but they're both important. Really, you stop like 90% of it if you have a continuous air barrier, and then you also have the added protection of the vapor barrier. And every code compliant building has these, but not everybody's like super attentive to making them continuous. And then the thing that happens when you're doing a renovation is that, does the building even have a vapor barrier? What era was it built in? What thing in the wall is functioning as the vapor barrier? What's functioning as the air barrier? And if I change this wall, or it could be roof, it could be floor, but if I change this building assembly, am I solving one problem and creating another one? So something that sort of gives me nightmares if I think about it too hard. In the 1990s in Nova Scotia, Nova Scotia had a pretty, we're a fairly progressive province in terms of codes. We had an energy code before there was a national energy code. And in Nova Scotia, we basically were required to put a vapor barrier inside our wall and 2 inches of foam insulation on the outside of our wall. And so that is like 2 layers of plastic keeping, wood and insulation in place. And I'm like, oh, how many of my houses that I built in that era are we gonna like find out that like they're a mold slick that are making people sick because of this situation that, buildings get a little wetter before they start to dry out. So I assume you were asking me that, Harvey, so that I would tell people not to put foam on the outside of a wall that has plastic on the inside. But something to be in mind, bear in mind.
Well, it does dovetail too into off-gassing as well. Like when you talked about spray foam, there are times that you want to use spray foam and there's times that you don't. And that's one of the issues. And I just think you really hit some really interesting things is surface temperature. What is it, 4 degrees of surface temperature on a window that a human being can't feel? And then it goes a little bit lower, then all of a sudden you can feel it. And so that's what happened, I think, with that window.
You feel it, but you feel discomfort.
Or warm, or whatever. No, so it's just interesting, the whole passive house of what you're doing and what we're all trying to aspire to. But I think for the next generation, it's something that they might as well get their hands on around now. And because this is the wave of the future, because the codes are all changing. You didn't get into it today, even though you did talk about it being it being Nova Scotia being progressive. Like Ontario is lagging, BC is sort of to a certain point is leading, but to be honest with you, I think that it's still too slow. And
it is too slow, and I think the thing, like both. I mean, BC is having a nightmare right now. There's roads washed out in Nova Scotia right now as well. Like climate change is coming for us, and I think that the public is going to ask for it so that the codes will just do what they're going to do. I think my message for everybody, especially if you're a young person listening, is that we're using science. It seems hard, but it's actually not that hard. Like we can totally do it. Like we just need to actually like for a very, very long time, our industry and most of our industry still is like, really, it's just about making it pretty and making things that are marketable. But we want you to know that you can have pretty houses and you can have houses that are also responsible. So.
Awesome. We've got one more question by Jim. And Jim, I don't know if you want to come out and ask your question about which way to push your clients, or if you want me to just read it and answer it.
Maybe Jim's gone. Maybe he fell asleep.
Yes. Oh yeah, he's saying feel free to. So, okay, so you're asking if, as a realtor, would you be better off to push your clients to passive new builds or buying lower and having the updates done? BS using purchase plus improvements. So, basically, I mean, I guess it depends on whether, Lori, I mean, tell me if you'd agree. We talk about this all the time, but it depends on whether you have a property, and if you're asking, should you tear down what is there and then build a new house, versus giving your client choices. But if it is the former, I think we always would say that it is better to renovate than to tear down and build new, because of all the, you know, the carbon and all the resources that are already in an existing house. It is always better to try and do a deep energy retrofit instead of like scrapping all that material and starting again from scratch.
I mean, buying
land and building new. Right. Well, I mean, it depends, I guess, on what, if your clients can find a place, and you know, there's a lot, as you saw in our early presentation, how context has a big part of it. So it really is very client specific. Like if they cannot find something that makes them happy, then maybe, you know, building new is okay. But yeah, I find it is sort of, it's hard to have a general answer on that. Do you agree, Lori? Or
yeah, I mean, I would say, you know, the most sustainable building is one that we already have. The embodied, the value of, you know, the embodied energy and materials in existing buildings is huge, and we're quite blind to it as a society. We're quite free with knocking down buildings and putting a new building where they are. So, but not every building is possible to salvage either. So that's a whole other night, I think.
Yes.
Yeah, thank you guys so much for your presentation tonight. It was really great. All the questions were really great too. We really appreciate everybody coming out. But yeah, that is all the time we have. The recording will be posted on Facebook and our YouTube channel as well. And we'll also be sending out an email with Habit Studio's information if there was any other questions that somebody wanted to ask. But yeah, that's all we have for time for tonight. So thank you so much.
Okay. Thank you.
Thank you.
Good.
Bye, everyone. Have a good night.
Bye.